We just can't get enough of Mars, can we? Everyone wants to go there, and astronauts are now looking at caves on the red planet where they can live once people inhabit it. The planet itself has some similar characteristics to Earth. Yeah, it's somewhat smaller than Earth, but the time it takes for the planets to revolve around themselves is also similar, which is about a day. On paper, Mars might seem like a good idea given some similarities to Earth, but there are some factors we need to pay attention to before we consider stepping foot there. The temperature. Mars might look like a scorching hot planet like a freakishly large Sahara Desert, but quite the opposite. It's really cold. Mars has a reputation for being a freezing, desolate, endless land that happens to have the largest mountain in our solar system thus far. So, within those mountains, astronauts and scientists are considering whether naturally built caves are the answer to our survival. Caves won't be the worst thing we'd live in considering our ancestors used to dwell in caves in communities. Logically, it's the best place to stay dry during a storm and keep warm. It's the best place for protection against predators like giant birds, elephants, and saber-toothed cats. We even had our first art shows in caves with evidence of cave art dated thousands of years ago. Caves are a good idea, and they can also help us save a lot of money when establishing a colony on Mars. Rather than building a fresh structure in the middle of an open plain, the cave structure will help and influence the architecture, potentially saving lots and lots of money. Going to Mars will be expensive. It's already expensive sending people to the moon and launching a rocket into space. So, we have to consider the logistics. Another thing to look out for is caves in the ground that are not necessarily stuck on mountains. Scientists believe that most potential places for humans to thrive are caves. These spaces are large enough to host large populations. So far, they identified 9 caves as large as football fields. So what would life look like if we lived in caves on Mars? For one thing, sunlight would be hard to access. By the time we reach Mars, we would have the best technology to maximize our lifespan in a hostile environment, which means withstanding the harsh sun rays of Mars. Most likely, we would dig through the caves further underground where oxygen would be pumped for everyone to breathe. People can walk around casually, thinking they're on Earth, and to exit the caves, you would need to wear a special suit. These cave colonies would have dormitories for people to live in and special spaces for colony meetings, entertainment, grocery markets, schools, and other places that are needed to sustain a colony. There would also be indoor farms to grow crops and raise livestock. A team of experts mapped out what some of the dwellings will look like on Mars. And just like on Earth, we will have apartments for young professionals, family homes, and luxury mansions. Some of the dwelling units would be placed on the surface and not in caves. One of the key elements of the design and architecture is how to build it around the natural light to brighten up the homes. Another element is how to deflect radiation and cosmic rays. Because Mars has such a thin atmosphere, sun rays and other hazardous objects easily enter Mars. The dwelling units also have to be sturdy to protect them from severe dust storms and extreme cold temperatures. Some of the living pods or dwelling units that are for couples or singles would have tunnels leading to a shared workspace and garden. Studies show that even being in the presence of greenery can reduce stress levels significantly. And on the red planet, we would definitely need some greenery. We can expect the family homes to be built within the caves, not necessarily underground. It would be tempting to head outside with the view of Mars, but the large thick glass would prevent anything from coming in and out. Those who are underground with a view rely on LEDs and camera systems to screen the surface landscape of Mars so it acts like real windows. And if you're bored of the surface, you can always switch the channel and watch something else as you please. Maybe a flowing river surrounded by trees, or maybe a penthouse view of all of New York. The choice is yours. There would be a driveway that leads to a garage so one can enter and exit easily. There won't really be a reason to exit the cave colony except probably to visit other cave colonies. In this case, we would have highly crafted vehicles that will take people from colony to colony on the surface. The vehicles can withstand harsh temperatures and would be constantly transporting people daily. Some people might live in a certain colony and have to commute to work every day in other colonies. Humans might not have to be working in dangerous conditions or on the surface. We would have robots that will do that for us. The thing about robots is that they don't need to be human-shaped to do a job. However, before transporting humans to space, we would need to create some human-like robots and land them on Mars. With the exact physical form, we can determine what would happen to people if they were on Mars. We would have robots for specific tasks, helping us with everything. Let's not forget artificial intelligence plays a major role in monitoring the systems and updating the functionalities of the colony. It'll know when certain systems need fixing, adjusting, renewing, and changing. We also need people to keep an eye out for anything out of the ordinary, and also to make sure people are behaving and not breaking the law. Getting to Mars would be the earliest obstacle we will face. We've already launched some robots to explore the terrain and conduct some studies. At first, we would send robots to test the conditions and to build most of the infrastructure. To build a proper colony, we would have to send out young couples willing to dedicate their lives to the future and the future of their children. It won't be easy. In fact, there would be a variety of people with different professions and specializations to help establish the colony. People would have to work and establish a local economy. We would need scientists, doctors, farmers, teachers for the children, and engineers to maintain the structure. It will take time for the colony to reach a substantial size, but it's all part of the process. Even the spaceships would need to be large and sufficient to house thousands of people traveling from Earth. Of course, by then, most of the dwelling units would have been built, and people would have already picked out their houses, depending on if they were single or if they were about to start a family. Once the colony has the necessary professionals it needs, then come the other people who wish to start their life on Mars. People would need entertainment, so musicians would find a place in the colony. We can't expect everyone to go out on a nice sunny day to the beach, but perhaps one day, when the colony is large enough, there can be an artificial body of water with the same elements as the beach. Livestock animals would also be shipped from Earth to be raised on Mars, where they can populate for our nourishment. We can also bring most of the animals and establish a wildlife sanctuary for everyone to enjoy and for the animals to thrive. For now, humans are planning on reaching the Red Planet sooner than we think, and who knows, maybe you can be one of the first people to sign up and have your own little dwelling unit far away from Earth.
Imagine something terrible happening to Earth and humans having to leave it as fast as possible, and you have to decide which planet will become your new home. Which one will you pick? Probably the first planet that comes to mind is Mars. It's relatively close. Like Earth, it's also a rocky planet. It even has an atmosphere, even though it's much thinner than what we have on our planet. But at the same time, the North Pole on Earth would seem balmy to you in comparison to Mars. On the red planet, the average temperature is minus 80 degrees Fahrenheit. The most radioactive areas on our home planet might seem harmless if you compare them with the surface of Mars. But what if we terraform Mars? Could we keep transforming the red planet until it becomes capable of supporting human life? It would be an enormous feat. Mars is an extremely dangerous place. Should you teleport there right now, without any protective suit or anything, the gas in your blood would instantly turn into bubbles. You can probably imagine the consequences. Add oxygen deprivation, cold exposure, and radiation poisoning to the equation, and well, who's next? If we still decided to terraform Mars, we would need to create a stronger magnetosphere. We've got this protective magnetic layer on Earth. It shields us from the sun's ultraviolet radiation. The red planet would also need a thicker atmosphere, again for protecting us from harmful space stuff better. Right now, the Martian atmosphere is almost entirely composed of carbon dioxide with tiny amounts of oxygen. For us to live there comfortably, Mars would also need to be warmer. And if we managed to somehow warm the planet up, we'd also be able to release frozen carbon dioxide. At the moment, there are vast reserves of this gas at the red planet's polar caps and other areas. It would help the atmosphere to become thicker, making it possible for water to exist on the surface of the planet. Right now, there is some water on Mars. The atmosphere of the red planet is too thin for this water to stay in its liquid form. But under the surface of the planet, it's a different matter. You can find water under the surface of the planet in its polar regions. The only place where this water is visible is at the North Polar Ice Cap. Also, sometimes salty water flows down crater walls and hillsides, and there are tiny quantities of water in the planet's atmosphere, but it only exists as vapor. If liquid water existed on the surface of the planet, it would make it easier for us to start growing plants, and plants, in turn, would begin to produce oxygen. But first of all, we would need to start the warming process. How? Well, Elon Musk suggests using nuclear energy to make Mars more livable. He says it could be done by creating a continuous flow of low-fallout nuclear fusion explosions above the atmosphere of the planet. It could create something like numerous artificial suns. It could warm the planet, melting the frozen ice caps, which would then thicken the atmosphere, causing even more warming. Other strategies for Martian global warming include the diversion of asteroids into the poles of the planet, or the large-scale production of greenhouse gases that could help us heat the red planet. Or we could create a giant space mirror, as huge as the side of Mars. It would reflect tons of additional sunlight onto the planet. The problem is all these projects would have exorbitant costs. They would also require serious upgrades in our technological capabilities. Could there be an easier and cheaper way of terraforming the red planet? It seems so. Casey Hanmer used to work in NASA's Jet Propulsion Laboratory. Now he's the founder of a startup hoping to create carbon-negative natural gas by pulling carbon dioxide out of the atmosphere of our planet. He's also made a proposal to terraform Mars for a modest $10 billion. Sounds alluring. So, what is his idea? Mass-produced small solar sails. These are already existing technologies, even though they appeared only recently. Such sails use sunlight to propel themselves, like ships use the wind to sail. These solar sails could be launched into low Earth orbit, and after that, they would fly themselves to Mars. There, they would reflect sunlight onto the night side of the planet. According to Hanmer's calculations, a decade of such launches could result in a 1% increase in temperature on Mars. Hanmer also believes that we could mass-produce solar cells at cell phone factories, all because a solar sail would need a processor, a camera for navigation, and some electronics to be able to transmit data, just like a smartphone. In other words, solar sails would be like small satellites using cell phone technology. Each of these sails would also need a sail of its own, a thin space blanket weighing about 2 pounds. When unfurled, it would span around the size of 2 basketball courts. Would this plan involving solar sails enable people to terraform Mars? Hanmer doesn't think so. Even if we put loads of money into solar sails, they would only make the red planet warmer and more humid, but they still wouldn't be enough to make Mars suitable for human life. Most scientists are also very skeptical about the very idea of terraforming this cold, dry world. They say that carbon dioxide and water vapor are the only greenhouse gases present on Mars, but there's just not enough of them to change the situation. Let's say we manage to melt the polar ice caps with the help of Elon Musk's nuclear technology or solar sails. And still, this ice will only release enough carbon dioxide to bring the atmospheric pressure to 1.2% of what it is on Earth. Plus, most of the carbon dioxide gas wouldn't be accessible, and we wouldn't be able to mobilize it. Even if we decided to go through an energy-intensive process of the extraction of carbon dioxide from the planet's soil, dust, and minerals, we'd still only get the atmosphere to a mere 5% of where it needs to be. Water is another problem. It is salty on Mars. It might even be as salty as the oceans on our planet. But these salts aren't what you find on Earth. If a person consumed a certain amount of them, they would be highly toxic to the human body. Who's next? On our planet, these salts are formed as byproducts of rocket fuel, as well as in road flares and fireworks. Naturally, they only occur in very dry areas. If there are no particular bacteria to break them down, these substances accumulate year after year and their concentration in water is constantly increasing. But in theory, it's possible to purify even such water. The process of filtration could help the astronauts get rid of 90% of harmful substances. Then they could use a UV disinfection unit. This would also help get rid of any foreign molecules, if there are any, that might be hiding in the water. This stage would not only protect the astronauts, but also prevent them from bringing any dormant Martian microbes back to Earth. In other words, future travelers to Mars shouldn't have too many problems with drinking water on the red planet, but only if they bring the right purification equipment that can deal with any water quality. Because, however bad running out of water in the middle of a desert is, experiencing it on another planet sounds much more terrifying. Anyway, back to terraforming the red planet. Once you start thinking about it, some worrying questions arise. Who is supposed to decide whether we should start this process? When should we start it? What if there's some form of life on the red planet, like indigenous microbes we haven't spotted yet, and our attempts to change their home will disturb them? What if they don't survive these changes? Now, what do you think? Share your thoughts in the comments. Hundreds of spaceships take off from Earth's surface and head toward Mars. Fast forward 7 months, and this space fleet of ships is near the red planet. Soon they will all land, and a few thousand people will become citizens of Mars. Perhaps they will never return to their home planet, because there will be absolutely all conditions for a comfortable life here. It takes time and many expeditions to create a self-sustaining colony on Mars. Here is how, step by step, people might build a full-fledged city there, with factories, hospitals, apartment buildings, and even clubs and restaurants. First, we need to pick a time to launch the rocket. A launch window opens once every 780 days. That's when the distance between Earth and Mars is the shortest. In this case, the journey will take about 6 to 7 months. Let's move to the launch pad. Here, we see the spacecraft connected to a booster rocket. Ignition! The booster sends the spacecraft into the air. It then undocks and lands back on Earth. At the same time, the spacecraft's engines start and it makes its way to Earth's parking orbit. To make this ascent, the ship has used almost all its fuel and now needs refueling. To do this, we use our booster again. A huge crane places another spacecraft on the booster. There are huge fuel tanks inside the ship. The booster launches from Earth and takes the refueler into orbit. It docks with the spaceship and fills it with fuel. The journey through space may need a total of 5 such refuelings. And for the first mission to build a colony on Mars, we need 5 spaceships. So that's about 25 launches from Earth. Considering that the booster costs $230 million, the refueler $130 million, and the ship itself is $200 million, the price tag on the mission is pretty impressive. So, ignition. Fast forward in time, and the first 5 ships descend to the surface of Mars. These ships haven't brought the first humans. They carry only payloads, like fuel and water supplies, oxygen for breathing, and medical supplies. There are also first living modules, waste management systems, and a huge number of solar panels for generating electricity. Before landing, one of the ships launches a system of satellites into orbit. It'll provide communication on the red planet. So, the robots begin their work on Mars. First, a whole bunch of little rovers line up and unfold solar panels. Their total area reaches the size of 7 soccer fields. They're much less efficient on Mars than on Earth. Frequent sandstorms fill the working surface of the panels with sand. But at the same time, the strong winds of the red planet also help to wipe the sand away. Other rovers, equipped with powerful drills, begin searching for water in the Martian soil. When they find water, people will begin producing fuel. We'll combine carbon dioxide from the atmosphere with the mined water at a high temperature and under high pressure. It'll result in getting methane for rockets and oxygen for breathing. Since February 2021, Mars Perseverance rover has been testing the technology for oxygen extraction. It has a box inside. This is the Mars Oxygen IRSU experiment, also called MOXIE. This thing pulls Martian air inside and then, under high pressure, takes one atom of oxygen from carbon dioxide. Such a thing, about the size of a shoebox, can provide enough oxygen for one astronaut to breathe. But if you build the same mechanism but the size of a large factory, it'll produce oxygen for an entire colony and release the rest into the atmosphere of Mars. Another group of rovers is working to turn the surface of Mars into a landing zone to prepare for the next step in colonizing the red planet. By this time, the robotic population of Mars has been working on these tasks for 2 years and 2 months, and people on Earth have been waiting for a new flight window to open. This time, not 5, but 12 spaceships are coming to Mars. 10 of them are cargo ships, which bring construction materials, fuel, and other supplies, as well as a lot of scientific equipment and 3D printers. 2 other ships carry the first interplanetary astronauts. The doors of the spaceships open, and 30 heroes set foot on the surface of Mars for the first time in history. These people are scientists, engineers, and doctors. They have undergone a strict selection and long training to become the first people to conquer another planet. And these guys don't have a return ticket. They'll have to stay on Mars for 2 years. The astronauts live right in their spaceships and try to get used to the unusual conditions on Mars. The temperature here is about minus 80 degrees Fahrenheit. Also, the gravity on Mars is 2.5 times weaker than on our home planet. That means a person here can jump twice as high and lift heavier objects. But the muscles in human bodies have a hard time getting used to such a difference, so astronauts can't work full-time. The first thing they do is unload cargo ships and deploy life support systems. Some people are experimenting with turning Martian soil into material for 3D printers. Others are setting up greenhouses and cultivating soil to grow plants. The human waste recycling system the robots brought here is used to make fertilizer for plants. 2 more years and 2 months have passed. We see a launch of a spaceship, not from Earth, but from Mars. The 30 astronauts have completed their mission and are on their way home. It's easier for spaceships to take off from Mars because the gravitational force here is less powerful. At the same time, ships are launched from Earth. They'll bring nearly 100 new inhabitants and even more cargo to Mars. When this space fleet arrives at the red planet, the astronauts can taste the first food grown here. 3D printers begin building homes on Mars. They print outer shells from Martian soil and plant waste. These shells will protect the dwellings from solar radiation and strong winds. And inside the shells, people will build permanent houses. They're inflatable and are equipped with modules brought directly from the spaceships. These houses have living bays, research bays, and communication centers. The construction goes on for 2 more years until the next flight window opens again. Some astronauts leave Mars, but more and more people come here with every new mission. They no longer live in spaceships. There are comfortable underground houses and 3D printed shelters. Most of the food is already produced on Mars. A new generation of robots works together with farmers. Other robots help to build even more houses to accommodate the ever-increasing human population. 2 more years have passed. Various space agencies launch their missions to Mars. There are more people, more scientific equipment, and even tanks with fish. In 2035, Mars and Earth are at a record short distance, so people send a huge fleet of ships with astronauts and construction materials. By this time, the human colony looks like a small city with many interconnected domes. Its inhabitants have already begun building an underground network of tunnels to move between houses, laboratories, and factories. They've also built the first hospital. 2 years later, the population of Mars reaches the 1,500 mark. Almost all of these people will become permanent residents of the planet. 4 years and 2 more launch windows later, the first restaurant opens its doors. Also, the construction of a nuclear power plant begins. Once it's finished, the Martians will no longer need constant supplies from Earth. From above, the colony looks like a small town. There's a farming section where food is grown, a living section, and a factory district. And with each new mission, people bring more and more solar panels. Now their total area equals dozens of soccer fields. All this allows the astronauts to feel at home. They also don't have to wait for food supplies from Earth. 20 years of the human colony on Mars. Its population is now about 30,000 people. Workers begin to bring their families to Mars. The first schools are built here. 30 years. The population is already over 100,000 people. The colony's infrastructure allows it to be completely self-sufficient. People produce enough food, get enough fuel and oxygen. Around this time, the first plants start growing in Martian soil. There's more and more oxygen in the planet's atmosphere. The trees planted in greenhouses contributed to this. The greenhouse effect from all the human activity helps warm up the surface of Mars, if only a bit. People still have to wear spacesuits when they go outside. It will take many more years until people will be able to breathe on Mars like they do on Earth. Gradually, rivers and lakes will appear. Green plants will cover most of the land. And then the inhabitants of Mars will be able to go outside without an oxygen helmet and call the red planet, now green, their home.
How about a mysterious object that used to orbit between Mars and Jupiter? At one point in the early days of the solar system, it was destroyed by some catastrophic event. This space body is called Phaeton, and this planet is totally hypothetical. But some people believe that the debris the planet left behind could have formed the asteroid belt. If you like this kind of content, please give it a non-hypothetical like and subscribe. Your support is very important to us. Thank you. Now, at the start of the 19th century, people hadn't discovered the asteroid belt yet. But in 1801, one astronomer spotted the largest asteroid in our solar system, Ceres. At that time, it was believed that a planet was orbiting between Mars and Jupiter, and Ceres seemed to be a suitable candidate. But the next year, another astronomer discovered one more space object with a similar orbit. It was an asteroid that was later named Pallas. These discoveries made scientists conclude that these two objects could have been fragments of the very planet that had once been dwelling between Mars and Jupiter. The following discovery of two more asteroids, Juno and Vesta, seemed to confirm this idea. Only in the 20th century did the hypothetical planet get its name, Phaeton. It was actually a name taken from Greek mythology, meaning shining one. The hero with this name was the son of the sun deity, Helios, who rode his solar chariot across the sky every day, giving humans the heat and light necessary for survival. One day, Helios allowed Phaeton to drive his chariot. But the sun didn't manage to control the horses. Everything went wrong, and Earth was about to burn down. That's why the main deity, Zeus, had to stop Phaeton with a thunderbolt. The idea of the asteroid belt being the sad result of the planet's destruction was called the disruption theory. And of course, there were several ideas explaining the planet's tragic fate. The most obvious one is that Phaeton was hit by a large space object. It could be another hypothetical body called Nemesis. Some people believe that it's our sun's companion star. According to this theory, the sun has a small companion star that has an extremely elliptical orbit. This orbit periodically brings it close to the Oort cloud, a large sphere of icy objects surrounding the sun. This, in turn, causes a lot of mess. It might be the reason why this hypothetical companion star was also nicknamed the Death Star. It might be a red or brown dwarf. But whatever it is at the furthest point of its orbit, it's believed to be about 1.5 light-years away. The search for this star has been in progress for decades, but no one has succeeded in locating this elusive and potentially non-existent space object. Anyway, back to Phaeton. Another theory claims that the planet could have suffered some internal cataclysm which tore it apart. But these days, the disruption theory has fallen out of favor. It was replaced by the accretion theory. According to it, the asteroid belt formed in the process of gradual buildup of particles initially floating in a gaseous environment. With time, they came together to create larger masses. Gravity pulled on these particles, encouraging them to stay together and form planetesimals, tiny planet-like bodies that later form real planets. Planetesimals kept colliding with one another, eventually developing into protoplanets. Such protoplanets grow until they form planetary bodies. As the mass of objects increases, the gravitational forces acting between particles become stronger too, continuing to build gas, dust, and ice within the nebular disk. It all has a snowball effect where the increase in mass results in more particles getting involved in the process. Eventually, there's no building material left, and large space objects float in the darkness of space. Now, many experts think that the asteroid belt is the remains of the protoplanetary disk which had once been orbiting the Sun before the planets formed. Unfortunately, it never had a chance to coalesce into a planet because Jupiter's gravitational effect prevented it from happening. In any case, even though Phaetons was a good story, it's not popular anymore.
Have you ever wondered what it would be like if every planet in our solar system was the size of Earth? Well, it's time to dive into this mind-boggling scenario. Let's imagine what each planet would look like if they were as big as our beloved blue planet. Would the barren red landscape of Mars suddenly become a lush green oasis? Would the massive swirling gas giant Jupiter just disappear? And how would it affect our solar system as a whole? Are we all doomed? Buckle up and let's find out. The first planet on our list is Mercury, the smallest planet in our solar system. But now, forget about the moon-like Mercury. Instead, picture yourself on the surface of a super dynamic incandescent inferno. There are a lot of craters and active volcanoes around you, and right in front of you is a huge, blinding bright sun. What a nightmare! But let's break these changes down. Well, along with the size of Mercury, both its mass and gravity would increase. In that case, it's possible that Mercury would have more atmosphere. Temperatures on Mercury are extreme, not only because it's very close to the sun, but also because of its very thin atmosphere. So during the day, the temperatures there reach 800 degrees Fahrenheit, and at night, it becomes terrifyingly cold, down to negative 290 degrees Fahrenheit. But now, when the gravity is stronger, Mercury could have a denser atmosphere, so the heat would be better distributed across the planet. And the atmosphere isn't the only thing that could make it hotter. If Mercury became bigger, it would likely experience increased internal heating due to gravitational compression. And hypothetically, its tectonic activity could increase. In other words, more interesting landscape, more mountains, and more scary active volcanoes. Congratulations, you've turned Mercury into Venus 2.0. For us, all these changes wouldn't be very pleasant. Now it would become much harder to send our spacecraft there, so it's better for Mercury to stay as it is, small, calm, and boring. Basically, the complete opposite of our next planet, Venus. So what would happen to Venus if it was Earth-sized? Actually, nothing. It wouldn't change at all because Venus is already almost the size of Earth. It's even called the Earth's twin, although twin is a big word, of course. In reality, we couldn't be more different. Venus is often called the morning star because it's so bright and visible in the sky. But don't let its beauty fool you. This planet is one of the most inhospitable places in our solar system. Its surface is hotter than a freshly baked pizza, around 900 degrees Fahrenheit, and it's covered in thick clouds of sulfuric acid that would dissolve any human who tried to visit. So, unfortunately, you won't be planning any trips there anytime soon. So let's move on to a planet that, unlike Venus, could potentially become a new home for us, Mars. Picture yourself standing on Mars's surface, watching the blue sunset and breathing in a refreshing breeze of air. Yes, you read that right, air. Moreover, you could be surrounded by plants, animals, and basically feel like you're on Earth. But how is that possible? Bigger Mars would have a stronger magnetic field and gravity. This would lead to a richer and denser atmosphere. It would likely have a wider range of gases, including oxygen. Wouldn't that be cool? Also, a denser atmosphere could distribute heat across the planet, so Mars would become much warmer and cozier. And here comes the most important change: liquid water. Mars actually has some frozen water at its poles and in subsurface reservoirs. But with a stronger gravitational pull, it could potentially stabilize liquid water on its surface. Hooray! However, it's not all fun and games. New Mars would also have a volcanic personality. It's already geologically active, but now its internal heat and pressure would skyrocket. That means more frequent and more crazy volcanic eruptions. Imagine how exciting it would be to witness such eruptions on another planet, if you managed to escape the consequences. In general, the planet could become greener and lusher, but not safer, although it would still be great to see it. But it's time to move on to the giants of our solar system. And if we're enlarging the planets before, now it's time to squeeze them really, really hard. If Jupiter became 11 times smaller, oh boy, what a disaster that would be. The first thing we'd notice is a change in gravity. And I say we'd notice because now we'd have no choice but to move somewhere. Jupiter experiences from 30 to 100 collisions with large asteroids per year. No big deal. All because of its strongest gravity, which attracts them all and protects us. But now our big protective brother has turned into a small baby. Say hi to a bunch of asteroids. Oh, and say bye-bye to Jupiter. This planet is known for its thick, swirling atmosphere. But with a weaker gravitational pull, Jupiter would probably have a hard time holding on to it. So over time, it would slowly escape into space, leaving behind a thin atmosphere composed mainly of nitrogen and oxygen. We'll also have to bid farewell to the iconic appearance of another giant, Saturn. The most noticeable difference would be the disappearance of its famous rings. Made up of small particles of ice and rock, the rings are a unique feature of Saturn. But with Earth's gravity, they would either fall onto the planet or scatter into space. Bummer. Saturn is also a gas giant, just like Jupiter. Its atmosphere is made up of mostly hydrogen and helium. But if it were Earth-sized, its gases would be compressed due to the increased gravity. This would make it much denser. That means Saturn's overall size and shape would change. Theoretically, if we squeeze Saturn hard, it could potentially become a brown dwarf. It's a type of failed star that lacks the mass to sustain nuclear fusion, but emits heat and light. So, Saturn could stop being a planet altogether. The weather on it would probably have changed too. All its crazy storms, such as the famous hexagonal storm at its North Pole, would have become weaker and calmer. The next giant is Uranus. Let's try to compress this poor fella. First off, the surface gravity on Uranus would be much weaker than it is now. Its atmosphere might also change. If Uranus was smaller, it could have a thinner atmosphere and different gases altogether. This planet is pretty chilly, with an average temperature of -353 degrees Fahrenheit. Ugh. But if it was the size of Earth, it might actually warm up a bit due to its reduced volume to surface area ratio. Don't get too excited though, it would still be way colder than the coldest spots on Earth. As you can see, gas giants don't easily go through all this shrinking, except perhaps one of them. Surprisingly, small Neptune would become much friendlier. For starters, it would probably be a rocky planet with a tiny atmosphere. That means no more gas giant, but instead, a planet that's easier for humans and critters alike to live and move around on. Speaking of movement, because of the smaller size, the gravity on this new Neptune would be almost the same as Earth's, making it a heck of a lot easier to walk and jump around. No more floating away into space. Now, the atmosphere of the original Neptune is so thick you could barely see your hand in front of your face. And the surface pressure is about 100 times that of Earth's atmosphere. But our new Neptune would be much different, with a much thinner and less dense atmosphere. It would still have some methane, water, and ammonia in it, but nowhere near as much as before. Finally, the temperature. The current Neptune is freezing, with an average temperature of about -370 degrees Fahrenheit. But if it was the same size as Earth, it would likely be much warmer, just like Uranus. Ah, that's more like it. What a planet that would be. That's it for the changes in the planets. But what would happen to the entire solar system if we made all the planets so small? It's hard to predict, but it's clear that their gravity and orbits could change a lot. It's unlikely that any of them would have flown into outer space, or crashed into each other, or something like that. But many of their orbits would probably become quite unstable, and the number of collisions with asteroids would have increased significantly. Of course, all this is purely speculation. It's not like we can actually test all this. But it's still a pretty interesting thought experiment, and it makes you appreciate just how unique and special our solar system really is.
What a nice cosmic family. Meet Mars. I bet you've met him before. These two little guys are Phobos and Deimos, Mars's small moons. But it seems like Mars isn't treating the little ones the right way. Phobos and Deimos are believed to be captured asteroids. However, Phobos is gradually moving closer to Mars due to gravity, and it is predicted that it will eventually be destroyed by the planet's gravity within the next 35 million years. I won't be around then. So, I imagine this will result in a ring of debris around Mars, similar to Saturn's rings. However, this process is a natural phenomenon and not an act of destruction by Mars. Apparently, Phobos is getting ripped apart by the crazy gravitational forces of the red planet. But wait, there's more! Phobos has these crazy parallel grooves all over its surface. We used to think that they were from an asteroid crash, but now scientists think they're actually from Mars's intense gravity pulling the moon apart. Talk about a rough ride! Scientists have this wild idea that when a little guy like Phobos gets too close to a big guy like Mars, it starts to stretch out towards it. They call it the tidal force. Phobos is predicted to get stretched out so much that it'll actually break apart. Crazy, right? And the debris from the moon will form a tiny ring around Mars, just like Saturn's rings. Now, some people thought that Phobos' tiger stripes were caused by tidal forces before, but that theory got shut down because the moon is just too darn fluffy. But now, these genius researchers ran some computer simulations and found out that maybe there's a hard shell underneath all that fluff that could create grooves on the surface. But don't worry. At the rate Phobos is going, it's going to crash into Mars in about 40 million years. But if tidal forces are already tearing it apart, it might not even last that long. However, we'll still have the chance to learn more about Phobos. NASA just picked 10 rockstar researchers from all over the U.S. to join the science working team for JAXA's Martian Moons Exploration, or just MMX mission. As NASA-supported participating scientists, they'll be helping JAXA explore the two Martian moons, Phobos and Deimos. And get this, they're even planning to land on Phobos and grab a surface sample. The mission is set to launch in 2024, and we'll get our hands on that sample in 2029. 7 of the lucky researchers will be using the MMX flight instruments to conduct their research. Phobos is a real oddball. It's only 17 miles wide and orbits Mars at a distance of 3,728 miles, to be precise. Now that's way closer than Earth's moon, which takes a whole 27 days to orbit us. But Phobos is in a death spiral toward Mars and is slowly falling towards the planet's surface at a rate of 6 feet every 100 years. But there must be a reason why Mars is acting that nastily, right? What if it's all just because of plain vengeance? Well, okay, picture this. Mars is minding its own business, being all hot and watery like a young Earth. It's got a sweet magnetic field that's protecting it from cosmic radiation and keeping its atmosphere nice and thick. Hey, life is good. But then, at least 20 asteroids, each the size of a small country, come crashing down on Mars like a giant game of cosmic whack-a-mole. One of them even leaves a crater that's almost 2,000 miles wide. Now imagine how Mars must feel with 2 asteroids being its moons after what other asteroids did to the red planet. All these impacts are like a massive punch to Mars's gut, and its already weak magnetic field is knocked out cold. The core gets all overheated and can't circulate properly, which means no more magnetic field to protect the planet. It's like as if you were wearing nothing at the depth of the Mariana Trench. If it were possible, you'd be defenseless and chilly. It's basically what happened to Mars. So now, poor Mars is out there in the cold, unprotected from all those nasty cosmic rays. It's like going outside without sunscreen. Not a good idea. But at least we can learn from Mars's mistakes and make sure Earth doesn't have the same fate. Maybe we should start investing in some asteroid insurance. But trust me, the red planet isn't mean at all. It's actually pretty friendly. While Mars may seem to be pretty tough for Phobos, there's something that might be thriving with Mars's help. So get this, A team of scientists found a way to grow rice on Mars. Yep, you heard me right. They used MMS, not the outdated way to send pictures, but a special soil called Mojave Mars Simulant. It's supposed to mimic Martian soil. And here's the catch, Martian soil has these nasty percolate salts that can be toxic for plants. So the team grew 3 types of rice, 1 normal and 2 gene-edited with mutations that make them better at handling stress like drought or salinity. And guess what? The mutant strains were able to root in soil with 1 gram of percolate per kilometer. Take that, Martian soil. But hold up. The rice grown in the MMS didn't turn out as great as the ones grown in regular potting soil. So the team decided to mix a quarter of the potting soil with the Martian simulant, and looky there, the plants started developing better. Now these scientists aren't just thinking about feeding Martians. They also want to see if their findings can help grow crops in places on Earth with high salinity. And get this, the whole project started when 2 researchers met for coffee and decided to try growing plants together. Well, isn't that nice? I suspect you're about to say, hey, but if you want to grow rice on Mars, you have to ship insane amounts of water from Earth, and it's not easy to quench this plant's thirst. You're right. You need about 449 gallons of water to only grow a pound of rice. But guess what? Scientists made a groundbreaking announcement at the Lunar and Planetary Science Conference in Texas. They found a relic glacier near Mars's equator. That's right, water ice on Mars, even near the equator. This is huge news, and could mean there's even more ice just below the surface. It's not just any glacier, it's a relic glacier that's estimated to be 3.5 miles long and up to 2.5 miles wide. It's like the size of a small town. It's got all the features of a glacier, including crevasse fields and moraine bands. But get this, it's not actually ice. It's a salt deposit that formed on top of the glacier while preserving its shape. So, how did this salt deposit form? Well, it turns out that volcanic materials blanketing the region might have something to do with it. When these materials come into contact with water ice, sulfate salts may form and build up into a hardened, crusty layer. Over time, erosion removed the volcanic materials, exposing the sulfates and revealing the glacier's unique features. This glacier is young, likely from the Amazonian geologic period. That means that Mars has had surface ice in recent times. Who knows what other icy secrets Mars is hiding? But hold your horses, there's still more research to be done. Scientists need to figure out if there's still water ice preserved underneath the salt deposit, or if it has disappeared entirely. And if there is still water ice at shallow depths near the equator, that could have major implications for human exploration. Imagine being able to extract water from the ground at a warmer location. That would be a game changer. So let's see what else these scientists uncover about our favorite red neighbor. Maybe someday we'll even get to visit that salt glacier statue in person. See you next time.